Symbols are critical for technical communication. They are not dependent on any specific language, being international in scope and character. Hydraulic graphic symbols emphasize the function and methods of operation of components. These symbols can be rather simple to draw if we understand their logic and the elementary forms used in symbol design. The elementary forms of symbols are circles, squares, triangles, arcs, arrows, dots, and crosses. Click on each of the following categories to see how these common hydraulic graphic symbols are logically constructed, giving symbolic representation of its component. A schematic is a compilation of graphic symbols interconnected, showing a sequence of operational flow. In short, they explain how a circuit functions. Correct schematic reading is the most important element of hydraulic troubleshooting. Although initially most circuits may appear complicated, recognizing standard symbols and systematic flow tracing simplifies the process. This circuit uses two sequence valves. They are normally closed valves that open at a predetermined setting. By tracing the flow in this circuit, we should be able to determine how this circuit is designed to operate. This process is called reading a schematic. Let's begin at the pump. Follow the flow past the relief valve to the directional control valve, which is shifted to the upper position as shown. The directional control valve directs flow to the lines in the upper circuit. Here, flow can go three places. The upper check valve blocks one passage. The closed sequence valve blocks another. But flow to the A port of the actuator is open. As the cylinder rod retracts, flow from the B port is blocked at the check valve, so it exits to the tank through the directional control valve. When the cylinder is fully retracted, pressure will build in the pilot passage of the sequence valve. It opens and sends pilot pressure to the directional control valve. Pilot pressure on the upper side of the directional control valve will shift the valve downward. Pump flow is now directed to the lower circuit, and the flow here goes to three places. It is blocked at the check valve and blocked at the closed sequence valve. But flow to the B port of the actuator is open. Flow in the port will apply pressure to the piston and extend the cylinder. Flow out of the A port is blocked by the upper check valve, so it flows through the directional control valve to the tank. When the cylinder is fully extended, pressure continues to build. Pilot pressure opens the sequence valve on the bottom. This sends pilot pressure to the lower side of the directional control valve, shifting it back into the upper position. Now, pump flow is once again directed to the rod side of the actuator to retract the cylinder, and the cycle begins once again. Tracing the flow in this circuit reveals that it is designed to keep retracting and extending automatically. Now that we understand the circuit, we may conclude that the proper function of the system will depend on the proper setting and function of the sequence valves, and the proper function of the hydraulically piloted directional control valve.